Okay. So without further ado, I'd like to welcome Annie Forrest as our presenter for tonight for the session titled Opening Up Math Problems. And I'm going to let Annie introduce herself and her role. So take it away, Annie. Thank you.
Hey, sounds good. So I'll bring up my slides so we can get started. And there we go. All right. So I am going to introduce myself, but I'm going to jump right into math first because why not? And then I promise I will share a little bit about who I am and why I'm presenting this. But up on the screen, you see a pattern that has 3 steps, right? So step 1, step 2, and step 3. It's snowflakes, which is probably not very appropriate for this time of year. Although, I don't know, it's close to Halloween and sometimes we get snow on Halloween, so you never know. But anyway, so a question that you could ask about this particular image is, if this is step 1, 2, and 3 of a pattern, how many snowflakes do you think would be in step 4? So take a second just to kind of have some quiet think time on how many snowflakes you think are in step 4, and pop it in the chat when you think you have something. All right, and looks like we're kind of all arriving at 15. So thinking about, all right, so yeah, step 1 had, oh, that was my question. Step 1 has 6, step 2 has 9, step 3 has 12, and so step 4 would have 15, right? Kind of growing by 3 each time. So we're going to be talking today about the difference between closed and open questions. So what you just sort of did right now was a closed question. There was one answer that we were sort of all supposed to arrive at, the answer of 15. So I'm going to contrast that with same prompt and something that's a little bit more open. So now taking a look at these snowflakes, if you can, maybe it's kind of hard in the chat. If we were in person, it's a little easier to describe. But if you would be willing in the chat, how do you see this pattern growing? So we've already kind of talked about that there's 3 being added each time, but not everybody sees that's 3 being added to the same spot. So take a second in the chat and see if you can kind of describe, you can use the words row or directional kind of language. Where do you see those 3 snowflakes being added each time? Great. Okay. So just kind of looking at some of the responses. So somebody said they saw sort of like a diagonal row, and I have a visual to show you in a second. Somebody else said they saw more of a column. So again, this is more of an open answer because it invites like different perspectives and different ways, and there isn't just one right answer. So here's kind of illustrating it. So if you saw a column of 3 being added each time, this is sort of the visual to kind of represent that. Here's like this triangle of snowflakes that like is over here now, and on the left-hand side, a column of 3, and then next time another column of 3, and that's kind of where some people see it growing. Another way that people see it is the diagonal idea, and somebody said this in the chat. So if you kind of imagine, here's the initial step 1, that's right here. And so a diagonal is getting plopped on the right-hand side each time, and that's where some people see it being added. And then some people see just an additional snowflake getting added to each row each time. And there might even be more, right? But those are kind of the 3 common ways that people see it. So I just wanted to like jump right into it and get our minds thinking about the difference between a closed question that has one answer and something that is the same prompt, but you can open it up a little bit more. All right, so I'm Annie Forrest. I will share my journey in a second, but right now my work is I work as a math consultant working in school districts in the Chicagoland area, mostly, well, they're all K-8 districts that I'm working with right now. But my path was, so I started as a teacher. I taught middle school math for 12 years. I worked as a coach for a while. I was a district math coordinator for a district, so I was doing K-8 at that time. I'll tell you, going from middle school to learning about elementary, I plopped myself on kindergarten classroom rugs, and that's where I did most of my learning to learn about primary math and get my legs under me, because just because you know middle school math doesn't mean that you understand elementary math. So I'm really glad I did that learning so that I could, do something like this, like a webinar, and share that learning. I went back to the classroom after a few years. Last year, I was teaching again, and now I'm working as a consultant. So that's kind of my journey and how I got here today. During that time of being like a math coordinator and a coach, I also was on the ICTM board and was ICTM president at one time too. All right, so what we're going to be talking about today, this idea of open and closed problems, I always want to kind of ground it in research and make sure it's not just, some new fad that we're sharing. So something that I always come back to, oh, and you know what, before I forget, in the chat, I have some notes to share with you and links. So let me pop that in there. All right, so in the chat is a document that has links to everything that I'm sharing today so that you can get to everything. But anyway, so this framework that I'm projecting on the screen here is called the TRUE framework. Basically, they did research about what makes for powerful math classrooms, and there's 5 dimensions. And again, the link is there if you're interested in learning more about it, but it's a really powerful framework for making sure that we're focusing on the right things when it comes to math instruction. So if we look at these 5 dimensions, here are sort of some clarifying questions that you can ask that help you sort of get to the heart of each of these dimensions of powerful classrooms. And we're going to focus in today on kind of these top 2. So first, we're really going to be thinking about the math. Like, is what we are doing, if we're going to open up these problems, is it grade level appropriate? Is it the content that we want? Is it giving opportunities for thinking and problem solving? And then also that idea of cognitive demand. And sometimes that's the synonym for that could be like productive struggle. But do students actually have opportunities to make sense of things? And do they have this chance to sort of engage in productive struggle? And what we're going to share about opening up problems today really gives an opportunity for cognitive demand for the range of learners. So I'm talking from people that get the answer in 2 seconds, done, I got it, down to the students that are struggling and not sure, if they are doing it right. How can we make something that's sort of naturally differentiated so that everybody is having the chance to have cognitive demand? And side note, cognitive demand is not equivalent to how hard a problem is. So we're going to kind of think about that today too. Making something more demanding doesn't mean that you have to make it a harder problem, or we're 3rd graders, so I'm going to give them a 4th grade problem to make it more demanding. We're going to think about opening a problem makes it more demanding, not by making it harder, but by making there be more thinking and problem solving involved. So I'm kind of trying to set the why here of why we want to open up problems before I get into the how. So I just wanted to share a brief story about being in the classroom last year. So I had a student, and I'm renaming him Ryan for purposes of the fact that you are all probably in my state. And but anyway, so Ryan was a student that was very well, he's a gifted student, identified as gifted. Got the answer quickly. That was important to him. And didn't struggle too much in math, but also had trouble being flexible in his thinking. And so when the parents came to parent-teacher conferences and they're like, how's Ryan doing? They almost were coming expecting just the praise that they probably had always gotten from math teachers in the past. Ryan's doing great. Look at his MAP scores. Look at how he's doing on the math tests. Look at all this accomplishment. And certainly those were the positives that I definitely started with. But then they did say, is there anything that he should work on? And I think they fully expected me to say next grade level, or maybe you should get him some high school math, or maybe a tutor that can, push him, or maybe he should take a college class. Like, I think they were kind of expecting that to be next steps. And I shared with them that I thought his next steps were to think more flexibly and to be more empathetic and listen to his peers and be able to work with others. So as you can imagine, this was probably not what they expected, and they felt a little surprised. Maybe not as, this is a this is an illustration, but they were definitely like a little taken aback. And it just made me reflect on the fact that how can we make things cognitively demanding for the range of learners? How can we open up problems to make it so that kids are flexible? Because I think we need to have maybe a better definition of what math success is. And we're going to talk about that in a second. So I don't know if you've ever heard of these 4 C's of 21st century learning. But the idea is, in this century of learning, it's not like in the past. We need to build all of these different skills: communication, collaboration, critical thinking, and creativity. When I was a coach for 2 years, I worked as a coach that focused in on innovation and technology. And so I had some colleagues, and we would do presentations on the 4 C's. And people would say, Annie, you're the math person, right? You're the math person. You do the PD on critical thinking. And somebody else that is more ELA minded, you're going to do communication, and somebody else is going to do creativity. And it was always like assumed that the only kind of important C of math, or the one that like really lent itself to math, was the critical thinking one, and the other ones were kind of more other subject areas. And again, so this is like, okay, I had this experience with this kid. I'm thinking about these 4 C's. I'm thinking about like, why is it that we assume that in math, it's all about just kind of getting the answer, the one answer? Another kind of piece I just wanted to throw out there as a reason to think about the opening up math problems is I think many of us assumed or were taught or think about math in a really linear progression. So you have to learn this thing before you learn this thing before you learn this thing, and you can't learn the next thing until you learn the thing before it. And certainly there are some obviously foundational ideas that build on each other. But again, being in the classroom last year, I taught 7th grade, and we had the ratios unit. And my colleague said, we can't get into ratios until we do a boot camp on fractions, because if kids don't know how to do fractions, they can't do ratios. And I noticed, well, certainly we needed to review some, basics of fractions. As kids were learning ratios, their knowledge of those fraction operations got stronger, or how fractions work got stronger. So it was almost like learning this thing later on in a progression made their knowledge of something earlier get stronger. So it sort of debunked this myth that it was a very linear progression and you had to learn things in a certain order. And so again, I'm like thinking about like, okay, how can I give access to everybody? How can I open things up? How can I make it more of something that makes kids be flexible in their thinking and connections between things, as opposed to just focusing on what's the answer to 1/2 plus 3/4 or whatever it is. I also just wanted to share, I did put a link on the document that I put in the chat, and I'll go ahead and put that. I don't know if anyone's joined since we've started, but I'll put that again in the chat, to a blog post that I wrote about our language. And so I don't know if this totally fits into this webinar, but I just almost can't do professional learning without mentioning how important it is to think about our language and how we talk about our students. I think we do this with a kind teacher heart when we talk about high kids and low kids, because we're trying to meet kids' needs and we want to do that. So it's not coming from a malicious place, but that shorthand way of talking about kids, I think, has some implications for their learning. And also for what our expectations are. So I'm just going to sort of challenge the norm of saying high kids and low kids, and focus more in on how can I make all kids think more flexibly? How can I give access to all, and how can I naturally differentiate something so that everybody is having a chance to participate? And so opening up these math problems, like we're going to talk about in a second, are one way that no matter who you are in the classroom and what your experience is and what your math anxiety is or what your perceived ability is, you are able to participate in contributing to some of these conversations. All right. I want to pause before we really get into the how to make these problems open. I just also want to talk about what we think of as math success. Again, building that case of why do we even bother making problems open? Because honestly, it can feel like a little additional work. So here, a couple of words are popping up on the screen that sometimes are associated with a student being successful in math. And I think all of these have importance and relevancy, and they're up there because they are words that we're looking for, right? We're looking for kids to have mastery, accuracy, fluency, achievement, all those things. Um, I have my next slide has also words that I've heard associated with math success. I think this slide maybe speaks to more of a focus on procedural understanding in math. Not right or wrong, but this one maybe speaks to people that are looking for more of a conceptual understanding in math. Again, not right or wrong. I think you need both procedural and conceptual understanding in math. But like all of these words are kind of like going into this idea of what is success in math. And one disconnect that I see is if you went to different people around your school and you asked them, what do you think is success in math? And you asked, for example, you asked parents, what is success in math to you? They might have a different definition or different words that they use than students would use. So parents are thinking, I want my kid to what? Get a good job, get into college, get into advanced classes, get into what, right? Get a good grade in your class, whatever they think of as math success. Students often would say similar, I want to get a good grade in this class. I want to pass. That's success to me. What would your administrator say if you asked them, what is success here? What does math success mean? I know that a lot of administrators have benchmark testing tied to their evaluation. So success to them might be test scores. And again, not coming from, none of this is right or wrong, but there's a difference. And then thinking to yourself, what do you value as success in your math classroom? And does it match what your colleagues would say is math success? So I want to take a second to sort of let you have some think time on that, but also um, encourage you. I'm going to give you an invitation to put something in the chat. It can just be a sentence. So it's not going to be a thesis statement. It's not going to be, you're not held to this. And this can change and evolve over time. But just as we're thinking about this idea of like, what is success to you in your math class? Can you write a sentence or two in the chat and just kind of formalize your definition of math success? I'm going to invite you to keep working on that and pop it in there if you feel comfortable. Um, And also feel free as people are putting their ideas into the chat to read through them and to add to your own definition. This is not a, a test where you can't look off each other's paper. In fact, it's helpful if you look off of each other's. And if somebody says a word that you're like, ooh, yes, that is so great. Like Kelly put in, something about multifaceted. Oh my gosh, what a nice, what a rich word that could mean something to you that you want to steal, right? So looking through people's ideas and, Kelly said something about reasoning and Mike mentioned about this conceptual understanding idea, right? So like, how can you steal all these words or looking back at some of these words that I had up here? Maybe one of these is like, yes, oh my, flexibility, right? That idea that Ryan was not very flexible in his thinking and only had one way to think about something, right? Steal these ideas. And then what I encourage you to do as you're reading through each other's responses and borrowing those words is to go ahead and make yourself an elevator pitch. As we start using these open problems, if you use them in your classroom often enough, once in a while, you will have somebody say to you, why are you asking them to do these questions? Right? Why are you focused on the right answer is 5. Why can't 5 is 5? Why are you making them come up with all of these different answers? Or if you ask kids to do something more conceptually or more visually, you'll have people, why do they have to do it this way? I just show them how to carry the one. Why are you making them do all these different strategies? I'm sure we've all had those experiences where it's just difficult for people that didn't learn a certain way to understand why we would be making math, quote unquote, like more complicated. So if you can kind of come up with your elevator pitch, and an elevator pitch is basically what you could say to somebody in the time it takes to ride an elevator with them. But anyway, you kind of have your response sort of ready to go for a curriculum night, for a challenging conversation with a parent, when an administrator asks you about why you're taking this approach, why are you using these open problems? You sort of have your elevator pitch ready to go so you can explain why it's important to you and why it's important to your students. So all that being said, we are going to get into finally now. Okay, maybe I've oversold it, but hopefully I've given you some language to kind of back up why we need to do these more open type problems. Okay, so in the document that I shared, there is a link to Marion Small's book. I'm not going to go too deep into it. She has a lot of good stuff in there. So if you want to take a deeper dive into this idea of open problems, that's a really, if you want to like a book that will kind of walk you through it, that's a really good resource. So this is a quote from that book where she says, "A question is open when it is framed in a way that a variety of responses or approaches is possible." So going back to how I opened today, you can either ask, how many are in step 4? And that's closed. And open was, where do you see those snowflakes going? So there's a lot of different types, and there's a lot of resources that are already made. And I promise I will share some of those because who doesn't love a good resource? But also sometimes it feels like I have 1,000 resources, but my district told me I am supposed to use this particular curriculum resource. And if you're anything like districts I work in, they like to use the word with fidelity. So perhaps you have heard that word before. So if you are supposed to use a certain resource with fidelity, how do you take that resource and use some of the problems that are right there in front of you and open them up? So I want to share that first, because I think a lot of us are, I've done a lot of curriculum reviews in the past couple of years. A lot of districts use their ESSER money to do curriculum reviews and adopt new curriculums. So many districts right now are either in the first years of a curriculum adoption or maybe even doing one. So let's say you have a book that you're supposed to use or resource or whatever it is. And here's an example of a closed question that would be like a word problem that you could find in any curriculum, right? How many nickels are needed to make 45 cents? And I'm imagining this must be in like 3rd grade, just because it's kind of using like it could be 2nd grade too. It's repeated addition, but I'm imagining in 3rd grade when you're kind of getting into groups of and multiplication. Closed question, there's one answer. I think it all has popped into our own minds what that answer is. So the way you take a closed question that is in your curriculum and you open it up is, first of all, you think about, okay, there's a known piece of it, right? I know that that there's going to be 45 cents. There's also this unknown piece, like that's what I'm trying to figure out, how many nickels to get to that known amount. And then there's also this piece of like a restriction, like they have to be the same coins, right? That's sort of implied by the nickels part, right? They all have to be the same. I'm trying to figure out how many nickels. I know it has to be 45 cents. So what you can do is those are like 3 different variables, and you can kind of play around with removing them or moving around which part is unknown or known, and that can open it up. So here's an example. You could take away the restriction. So I'm using the same problem from my curriculum, and I'm just taking away the restriction that they have to all be the same coins. So now I just say like, well, how many coins does it take to make 45 cents? And now it's open, right? So the kid that got the answer in 2 seconds for the original problem has a much bigger cognitive demand because there's more than one answer here. So they can't be done in 2 seconds and you can go, well, what else could you come up with? Or can you come up with all of the possible answers? And that student has something to continue to work on. And a student that's struggling might have some manipulatives in front of them and they're working on building that or thinking through it and coming up with some responses as well. So just removing the restriction right there opens it up. You can also take away the known. So like I have a closed handful of nickels. How much money do I have? I have some nickels. Okay, well, that's keeping the restriction because they still have to be all the same. They still have to be nickels. But now it could be all, and then you could be talking about multiples, right? And so it's kind of getting at that same idea. You could, now this gets a little more complicated, but you could like swap the known and unknown and change the restriction a little bit. But basically, like, okay, I have 5 coins. 3 of them are saying, how much money do I have? Again, there's more than one right answer here, and it's just making it a little bit more open. By the way, if you want these particular examples, they are linked. There's like a link from the Enrich website on the document that I shared, and all of these examples are in there. So don't worry, you don't have to like be writing them down. But anyway, you could swap the known and unknown, and you could remove the restriction. So I have 5 coins. How much money could I have? Again, it's all just versions of the same problem of just like playing around with what you know and don't know in the problem and what all the possible answers could be. Do I have another one here? Oh yeah. I have some coins in my hand. How much money do I have? That one's really open, right? That's tons of possibilities. And sometimes even you can start with something really open like this, move towards more closed as you go. And then you could even end with the more closed question that you're trying to get at if you want to. But starting with something super open lets everybody participate and everybody is getting that kind of cognitive demand and problem solving aspect that doesn't just have one quick answer that one kid's like done and then everybody else is like, well, I don't need to work on it. So anyway, that is kind of the procedure for opening up a problem that you already sort of have in front of you. And I have not been looking at the chat. Has anybody shared any? I don't think there's been any questions. Okay, good. All right. Feel free to pop questions in, or we're a pretty small group. Feel free to unmute if you have a question as we're going. All right. So let's take a second and just try. So again, there's lots of ways you could open it up. Think about taking away the restriction. Think about how you could remove some of the known or the unknowns or flip that around. So here's the closed question. Nate has 7 pumpkins. Dean has 4. How many more pumpkins does Nate have than Dean? This is kind of like a classic first grade problem, a comparing problem. And if you don't mind, I invite you to put into the chat a way that you had thought about opening this problem up. Let's see if we can come up with some open versions of this. And as you're kind of thinking about your problem, feel free to keep popping them in the chat. I want to point out, since Kelly put some ideas in the chat too, sometimes a problem when you open it up really helps kids make connections between different ideas. This problem is a classic first grade problem that you find in the subtraction unit, but it's a comparing problem. And I happened to be in a classroom the other day where a teacher was talking about a problem that was a comparing problem like this. And she said, oh, so it's going to be 7 take away 4. And we had an interesting conversation afterwards about like, okay, she's like, well, it's in the subtraction unit. And I said, totally, I see where you're coming from, but like the action in this problem, right, is not Nate had 7 pumpkins and Dean took 4 away from him in a takeaway type situation, right? It's like Nate has a stack of 7 and Dean has a stack of 4, and how much bigger is the other? And when Kelly opened up the problem, it ended up having them put their pumpkins together, right? Because they both have a stack of pumpkins. So it's kind of making the connections between different ideas and the action that's actually happening in this particular story. So sometimes opening it up actually helps kind of even kids understand the context a little bit better. Awesome. Yeah. And, I tried to have a reasonable context here too. I was teetering on the edge of being one of those weird watermelon problems where like, who has a trunk full of like 57 watermelons, 7 pumpkins is really teetering on the edge of like weird, but I thought it still worked. Plus it was seasonally appropriate, which we all love. All right. So anyway, that was the ones that you can open up yourself, and you can do that with any problem that you have in your curriculum. But I did say I would share some resources, and these are probably my 5 favorites, especially for elementary grades. But I know that Mike said he's at the middle school level, and these work at the middle school level as well. So maybe the first 2 are a little geared more towards elementary, but the other ones definitely are for all grades. So the first one is a structure that's just called how many. Not that I'm trying to like sell you resources or books that you have to buy. But if you are looking for something, in contrast, I first want to show you, these are just some counting books that I found around my house. I have 3 kids of my own, and being a math person, math teacher, people are always gifting, oh, like your kids would like this counting book, this counting book. And I do like all of these books, but these are pretty much traditional counting books, right? Like there are things to count with a closed answer. How many ladybugs are on the page, right? We're going to count the Chicago things, and there's a correct number of I forget, deep dish pizzas on one of the pages or whatever. And it tells you sort of what to count. So these are closed in a way that they are just like certain things to count. And I think they have their place. They're not bad. But if you want to open up counting, the way that you can do that, and again, this is especially nice for primary grades, but everybody really can benefit from some of these ideas. But there's this book that's called How Many? And here's an example of a page from How Many? So you can see that on the page, there's like all these halves of avocados. Some of them have the pit in them, some of them don't. At the bottom are other ingredients. And so the prompt for this is just simply how many? And so you share this with students and you just record their answers. It's super open because kids might count how many halves there are. Some kids might say how many full avocados there are. Some kids count the pit, some kids count the tomatoes, some kids count, and they do things that are super interesting. And even if it's upper grades, this is a pretty nice array or groups of how many, halves of avocados that you could even use as you're thinking about multiplication or beyond. So just opening up a prompt, showing an interesting picture and just asking how many, and not saying, and then, but the first time you do this, kids will be like, what? How many? What? Like, what am I supposed to count? Because honestly, kids, even in kindergarten, are used to there being one right answer in math. And so even just the benefit of doing more open problems is getting kids to be more flexible in their thinking and realizing it's not just about being fast and right in math, right? There's flexibly thinking about things, creatively thinking about things, listening to other ideas is really important. So super easy. You just find nice images or go ahead and buy yourself this great book and ask kids how many and how they would count them. Okay. Oh, and this is a quote from the author of that book. He just says that what counts as one is one of the most important questions in elementary school mathematics. So just, again, deciding what you are going to count when you're counting something can be really powerful. Okay, The next one, I'm going to have to kind of get away from my slides because I want to show you the actual resources. So the first one is, or not the first one, but the first one that I'm going to get away from my slide is called Math at Home, and it's from the Math Learning Center. So this resource was developed during the pandemic, actually, to have some resources for teachers or parents to use, especially when we were not live with kids. But luckily, they came up with a bunch of good prompts, and so they archived it on this site. Again, the link is on the document I shared with you. But they put them all here, and now you can use them in the classroom. And also, what I like about it is sorted by grade level. Not that you can go in any of them and find things. But like, for example, let's say you taught fourth grade, you could click on your grade level. And then you also can click on your domain that you're working on. So again, if you're supposed to be using a certain curriculum with Fidelity or whatever, you can make sure you're finding the correct content that relates to whatever it is that you're doing. But let's say, I don't know, you're in fourth grade and you're thinking about multiplicative reasoning. Then there's all these prompts that you can use. So I don't know. Let's see. Let's just click on one. Well, this is kind of nice. So they use this routine a lot of just like, here's today's number. Today's number is 36. You could put that up on the board. How many ways can you show today's number? Right? And so super open. Lots of kids can participate. Kids could use tally marks. They could use multiplication facts. They could write a number sentence with addition. All different ways that kids can kind of participate. And then having the discussion around it is what really helps kids build that flexibility, because they're somebody that decided to use multiplication, the next day you do another one, and a kid could be like, oh, I'm going to steal that strategy from yesterday and use it today. So it really helps kids build their flexibility in thinking about these. But anyway, lots of different ones. I love that they have some would you rather. Again, nice conversation opener, and also makes it more open and done for you and cute and colorful. And, we all like that kind of stuff too. So that's a really nice resource. It's, like I said, from the Math Learning Center, but free to use for everybody. The Math Learning Center does have a curriculum. It's called Bridges, if you've ever heard of that, but they have a lot of free resources that you can use. So this link particularly is curriculum agnostic. It does not have to go with that curriculum. All right. So that was Math at Home. Okay, open middle problems is another one of my favorites. And I'm just going to switch to a different browser because I kind of had it queued up, ready to go. Okay, so this site is called Open Middle. And I have it open here to the About page just so I could kind of show you this part right here. So in Open Middle, again, we're talking about open problems, but these are specific that the middle is open. So a closed beginning would mean that they start with the same initial problem. A closed end means that they end with the same answer. So an open middle means that there's multiple ways to approach and ultimately solve the problem. So the middle of the problem is open. So I'm going to show you I'll show you a fifth grade example first. So the prompts sort of look like this. Again, already done for you. They even have them all on Google Slides, ready to use. But here's a fifth grade example just to kind of show you how they work. So it says you're going to use the digits 1 through 6 at most each one time. You would fill in the boxes to make the largest or the smallest number that rounds to 5. So again, if you're working on rounding in fifth grade, you can come up with a worksheet of round this to the near, round this, now round this, now round this, right? And there's one answer. This does have an optimal answer. Okay, so that the middle of this one is open because, again, that's a little bit different, but I have noticed that kids have a hard time. If you print this on a piece of paper and they have to use paper and pencil, they have a hard time with this because it's hard to rearrange. So if you do any of these open middle problems, I do suggest like either having Post-it notes or tiles that they can kind of move around into different configurations, or even on a dry erase sleeve, print it and put it in, and then they can at least like quickly erase if they want to try different stuff. But this website's nice because it, for you as a teacher, it gives you kind of a hint that you could like say, just if they're really feeling stuck, what a hint you could give. And it also has like an answer key of, what the answer is going to end up being of the largest and the smallest that you could make to round to 5. This resource is another one that is nice because it goes by grade level. So let's say, again, you're teaching 5th grade, and then again, gives you the domains. So you can find something that aligns exactly to what you're learning about and have some open middle problems that go along with it. Super engaging for kids. Also, the cognitive demand is very high because, again, to get the optimal answer takes some strategy. So some kids will use strategy to sort of figure it out. But if you are struggling, you have an entry point because you can at least just try something. Like randomly put numbers up there and see if it rounds to 5. Nope. Okay. Rearrange it, try again. And think about how much repeated practice a kid gets by, even if they have to do guess and check. They are doing a ton of practice on whatever it is that you have up on the screen. So that is another great resource. Okay, hold on. I don't want to ruin my flow here, but I got to see what my next one on my list was. What did I have next? Oh, which one doesn't belong? So, all right. Which one doesn't belong has been around for a while, and there are 2 sites currently that are sort of like living out there on the interwebs for which one doesn't belong. The original one is this one, and again, I linked both of them on your site. I'm sorry, on the document. So this site is the original one. It was maintained by somebody for 10 years. She kind of got she doesn't want to have to maintain it anymore. Her life is just a little too busy to keep working on it. So that it did expire for a couple of, like maybe a month. It kind of went away. It's back. I don't know how long it's going to be back. So I put it there so you can get to it. But I also put a link to Christopher Danielson, again, who I referenced earlier. Now it also has a home on his site. So you have both links. If you are familiar with the previous site, now you have the new site too, where he archived some of the ones from the previous site, and he's going to be adding more as well. So I don't know. I think I'd go for this site just because I think there's going to be new ones there appearing too. But which one doesn't belong? Just real briefly, if you are not familiar with this structure, you basically take a prompt, and we can even just look at any of it here. Let's just look at, I can't zoom in. No, won't let me. Okay, fine. I'm going to stop making you dizzy. Let's just look at this first one. So you would just put one up on the screen, and you just ask students which doesn't belong and have them give a reason. And so the idea here, it's super open because, again, there's more than one right answer. We could come up with a reason why each of them doesn't belong, and we could probably come up with multiple reasons why each doesn't belong. I have done this particular one. I'm just happen to be on this site right here with this orange shapes one. I have done that particular one with kindergartners and 8th graders, like the rank. I've done it with every grade level, kindergarten through 8th grade. And it's very interesting what kids say. It's language, like middle school language comes up with 90-degree angles, regular hexagon, like those kind of words come up. And in kindergarten, just as rich conversations, but they're using their words that they have. Always comes up that there's a big debate. Is this a piece of pizza or is it a triangle? Love it. Like that comes up in kindergarten all the time. But anyway, so these prompts are appropriate for everybody. If you're doing it, since Mike mentioned middle school, if you're doing it with middle school, I would still do something that was more shape-based the first time you do it. And then you can always go into the graphs or something that feels more middle school. Yeah, I wouldn't do that with kindergarten or primary, but I'm just sharing for middle school. Like before you do something super like diving into the math, I would do something that shapes. But anyway, it's another really nice resource that has a lot. All right. The last resource that I'm going to share before we wrap up today is something that's called Slow Reveal Graphs. So this resource, if you are ever working on, and all of us are, right, reading graphs, or there's always a closed question. And you can see that I, on purpose, on these slow reveal graphs, have removed all of the numbers and the labels on this. And that is what's going to make this more open. Again, I linked for you this resource. These are already done. So I happen to know, so the creator of the website, her name is Jenna Laib, and she made all of these, and they are Google Slides ready to go. So if you need something tomorrow and you want to do a slow reveal graph, I'll show you her website and how you can find these. But anyway, you put it up like this on the screen and you just say, what do you notice? What do you wonder? Okay. So we have a few minutes here. I think we have enough time. I'm going to invite you to, in the chat, just tell me one thing either that you notice or one thing that you wonder about this graph that you see in front of you. Again, super open. There's no right or wrong. It's what you notice, what's coming up for you as you look at this graph. And I'm just going to go ahead and read out a couple of the things. So Kelly said there's 5 things that are equal. Tony also noticed the first 5 are the same height, right? So, okay, that's standing out to a lot of us. Like something is the same and then somehow isn't the same, right? And so we might be, right, a question that we're kind of thinking about then is like, well, like, what is this about, right? Did it go to the next slide before I was ready? Okay, that's okay. All right, so the next slide here, you see it's labeled dog, cat, orca, butterfly, fish. So any thoughts or predictions? Before I put it up there, Mike said maybe it was time. Okay, but now that we see these labels in the chat, go ahead. What could this be about? What do you think it is that all dog, cat, orca, butterfly, and fish have that's the same? And yeah, and that blue bar is going to be like extremely more than the dog, cat, orca, butterfly, fish. So what is like going on? I'm guessing maybe this is animals. And something about those first 5 all have the same. And we're like, okay, it's not ear, so if you're in the classroom, it's not ears, because dog and cat both have same amount of ears, but then we got orca, butterfly. Uh-oh, that doesn't work. All right, you're thinking in your minds. Ooh, Kelly's thinking about eyes. And I'm going to pop up the numbers over there. And let's see if that would make sense for Kelly's idea about eyes. Okay, so maybe, right? Because we are at 2. And so 2 eyes on the dog, cat, right? That could make sense. And so if it is eyes, if it is number of eyes, as Kelly predicted, right? What are these other animals then, I'm sort of wondering, right? And so then you can kind of like have a good conversation about that. Now, careful, because you always have the animal lovers in your classroom. So use with caution if you have some kid that is like an expert and goes into a, long dissertation into their study of all bugs that they know about. But you kind of can start going, I didn't know a praying mantis had 5 eyes, but some kid would know that. Jumping spider, sunstar. Any thoughts on that big blue one before I do it? Yeah. Box jellyfish. Now we know it has 24 eyes. You learned something new. Even if you already knew about open middle problems today, you learned something new because a box jellyfish has 24 eyes. But super awesome for data often is in a unit that gets lower priority because we run out of time or it's not identified as one of the major clusters for a lot of grade levels. So these slow reveal graphs are also nice, just tuck in like a little warm up or before when you get back from lunch, before you go to specials, when you have a little bit of time, like it's a nice little like activity that you can do. Even if it's not connected exactly to what you're learning about in class right now, because first of all, they're really engaging and kids like them, but also it gives you a little bit of exposure to how graphs work. So the website, I'll just show you kind of how that looks. when you come here, feel free to poke around on everything, but I'm just going to direct you right here. There's a drop down and it takes you to graphs for elementary classroom. So right there are the ones, and you can see I found the eyes one here, but there's lots of different ones. You click on them and then you just click on the slide deck and poof, you have it. So you don't even have to make them. You can, again, if you need to use the graph that is in your particular curriculum resource, you can see how these all work, and you can totally put them up there and just put a box around the numbers and have kids do it that way. But if you'd like some that are already made, this resource is really nice. All right, I talked a bunch. That's the problem with webinars, is it's a lot of the presenter talking and not as much of the people talking, which, I mean, I like to talk, but sometimes I get sick of myself. But hopefully that was helpful. Hopefully you got a couple of ideas. I have my contact information on the sheet that I shared with you at the beginning. And I want to make sure I give that to you again before you pop off. But if there's any questions or anything else that people want to ask about, or any of these resources that you've used particularly and you want to share, oh yeah, slow reveal site again and show. Yeah, Kelly, what do you want me to show?
Could you show again where that last, I was trying to figure out myself and I didn't see what you did.
Yeah. So here on the slow reveal graph is the link right here. It takes you to this website. And if you go to classroom resources, there's a drop down that takes you to graphs for elementary. And then there's all these other ones as well. Some of them are a little bit more mature themed or harder, types of graphs. So that's why I kind of pointed you to this if you teach K-5. But feel free to poke around at any of them, or just even to see the structure of how Jenna lays out them and how she walks through revealing the information. Because once you sort of see that structure, you can take any graph from your curriculum, plop them onto a Google slide, and just use a white box to cover up the information and have it be slowly revealed to kids. It's just a really more engaging way to have kids interact with these graphs before we plop it all up there and just start asking them the closed questions, right? Who has the most? How much more? How much more is this one than that one? Kind of opening it up first. Anything else or any other questions before we go?
I was going to say I love the slow reveal, especially at the K-5, pre-K-5 level of other subjects, as the elementary teachers are teaching all subjects. Just a great way to bring the math into the science, or the science into the math. And so very cool, very cool.
Yeah, and if you're a K-5 teacher and you teach all the subjects, right? You can do some of these things when you're doing science or whatever. So awesome.
I think too that we can remember that I kind of mentioned it in the chat earlier, but some of these students that we come across have these experiences repeatedly feeling like a failure in math. They just can't find that part of the math that they're really good at. Some of these problems that you've showed today, it's been phenomenal. I've even just really enjoyed the resources you shared, but you have to remember those are open invitations to engage in the math. And so when they know that no matter what they say, when they choose to answer something, that it's going to be okay because everything is kind of right in these situations. I just really feel like that gets our students some of those feelings of success. And so they're more likely to engage the next time and the next time, even when it's challenging. So thank you so much. This was really, really great.
Awesome.
Does anyone else have any other questions for Annie before you guys hop off? I know there were some kind of good questions along the way. So.
Annie.
All right, Mike, I hope that helped satisfy
Thank
your.
you so much. That was great. I loved it. Yeah. No, that's
Yay.
great. And it's kind of right in line with what we're doing in class, and like a lot of new little resources that I can love. And I also love that slow reveal graph. I thought that was really cool.
Awesome. See, that's why I saved it for the end. I was like, this is the reward for anybody that makes it through the whole webinar.
Yeah, it was great, but the whole thing was great. Thank you so much.
All right. Thank you, guys.
Yeah, please do complete the checkout form as well, and I will post it one more time in the chat. Otherwise, Have a great rest of your day. Thank you guys very much. Thanks, Annie.
Thank
Thank
you.
you.